Okay, we're going to look at sum and difference of angle identities, and we need to find the values of sine and cosine using the sum and difference identities. So the first thing we need to do is look at the sum identities. So for the positive, angles, so the sum identities, we have the sine, which is a plus b, and the formula for this is sine a cosine b plus cosine a sine b. And if we're doing cosine will be a plus b, and it's the cos of a, the cos of b, and it's minus sine a sine b. And if we're doing tangent, so we have tan of a plus b, so this will be tan of a plus the tan of b, and this is divided by 1, and if this is a positive, this will be minus, so it's 1 minus tan a tan b. So this is the sum. So now we're going to look at the difference. So the difference is the negatives. So the difference, so we've got for sine, so this is when we have a minus b, we need to use the sine of a, the cosine of b, minus the cos of a and the sine of b. If we're using the cosine, and it's a minus b, this is going to be cos of a times the cos of b, and it's plus sine a sine b. And if we're doing tangent, and this is a minus b, it'll be tan of a minus tan of b, and this is positive because that's negative. So tan of a and tan of b. So those there are the identities, and it will depend on our angle. So let's have a look at an example. So example 1. Find the exact value of each expression. And the first one, we need to find the exact value for sine 105 degrees. So what we need to do is find two angles that will either add or subtract to make 105. And if we think of our special angles, if we can use those, that would be easier. So sine of 105, we can use 60 and 45 degrees. So we're going to label these as angle A and B. So we can use, because it's positive and it's sine, it's going to be A plus B, which is sine of A cosine of B plus the cos of A and the sine of B. So this will be substituted in, so sine 60 and cos of 45, cos of 60 and the sine of 45. So now we can either use a unit circle or we can think about our special triangles, or if you're able to use a calculator. So the sine of 60, this is root 3 over 2. Cosine of 45, this is root 2 over 2. Cosine of 60 is a half. And the sine of 45, root 2 over 2. So we can simplify, and we're going to multiply. So root 2 times root 3 is root 6, and that's over 4. And root 2 over root 4. So to put this over the same denominator, we have root 6 plus root 2. And that's our answer. Right, a second example. We have a negative angle this time. So we have minus 120. So we need to think of two angles. The one that's subtracted will give us minus 120. So I can do 60 minus 180. And this will give me a negative angle. So this is A. And this is B. So we have cosine and this A minus B. And the formula I need to use is cos A, cos B, plus sine A, sine B. So that is cos of 60, cos of 180, sine of 60, and the sine of 180. And then if I work these out, so cos of 60 is a half, cos of 80 is minus 1, sine of 60 is root 3 over 2, and sine of 180 is 0. So I just have minus 1 times a half, so the answer is minus a half. So the guided practice question, we have sine of 15 degrees. So there's a few different ways to do this, but I'm going to use my 45 minus 30 degrees. So this is going to be my A and my B. So sine, so negative, so it's A minus B. So we have sine of A, cosine of B, minus cosine A and sine B. So that's our formula. And I'm just going to substitute in the values. So sine 45, cosine 30, minus cosine 45, and multiplied by sine 30. So the values, so sine 45, that's going to be root 2 over 2. And cosine of 30 is root 3 over 2. Cosine 45 is root 2 over 2. And sine of 30 is a half. So if we multiply these, we'll have root 6 over 4 minus root 2 over 4. And we just write over one denominator. And there's our answer. So root 6 minus root 2 over 4. Okay, so now we have sine of pi divided by 12. So the first thing we need to do is convert this to degrees. So this is going to be pi 12 multiplied by 180 divided by pi radians. And our pi's will simplify. And then 12 will divide into 180 15 times. So this is going to leave us with 15 degrees. So the sine, we want the sine of 15 degrees. So we've actually just worked that one out. I think that was sine of 15. It was. But let's try if we do it, instead of using 45 and 30, what if we use a different angle? Does it make a difference? So let's try 60 and 45. So sine of A minus B and sine of A cos B minus cos A sine B. And we'll do sine 60 cos of 45 minus cos of 60 and sine of 45. Okay, so sine of 60 is root 3 over 2. Cos of 45 is root 2 over 2. Cos of 60 is minus a half. And sine of 45 is root 2 over 2. So if you multiply this out, we have root 6 over 4 and minus 2 root 2 over 4. So our final answer, which you'll see is the same as what we had before. So we can use any angles as long as they have a difference of 15 to work these out.